Okay, so we are setting up a proportion based on similar aspects of the triangles up here. So if you're noticing, the base for the small triangle EFG is 2, so I put a 2 right here. And then I say the base for the larger triangle is 5, so I put a 5 right here. And so if you recall, we said that the height of the smaller triangle EFG is h. So I'm putting, well, the height of the smaller triangle is x. So h, which is height, equals x. So I'm putting the height over here. And then because we don't even know the height of the full length, this part going from F down to the bottom, we don't know that height. We just put down our letter h here. Okay, and a proportion again is when you set up two ratios, so basically two fractions that equal the same. So the values would equal the exact same. So that's called a proportion. So the next step of proportion is to do cross multiplication. So here I'm doing 5 times x is 5x, and then I have 2 times h is 2h. Okay, so notice how up here at the top, I determined the height of the large triangle by solving for h. So you remember we had 5x equals 2h a moment ago, and you had to divide by 2 on both sides because you're solving for h, and that leaves h equals 5x over 2. So remember that height is like this entire height here. So don't be alarmed if you don't see an actual whole number for this. Sometimes problems on the GRE will work out to be this complex. So the next step here would be to subtract the height of the small triangle from the height of the large triangle to find the height of the rectangle, because you remember the goal was to find the area of the rectangle. So remember, we need to subtract this off of that 5x over 2 so that we can find out just this part. So here what I'm doing is I'm saying 5x over 2, remember that's the height of the large triangle, minus x, which is the height of the small triangle, if you remember that, and I'm moving over here. Now look at this x as just a whole number. Any other time you work with fractions and you're subtracting or adding, you're always needing to make sure that the denominators are the same. In this case, the denominators are not the same. So the denominator here is 2. The denominator under this x is an imaginary 1. And that's always the case when you have a whole number, in this case, a whole variable. So I went over here and converted the second fraction, this x over 1, by multiplying the numerator and the denominator by the denominator that's here. So I can assure that I have the same denominator. So I multiply by 2 at the numerator, 2 at the denominator. And over here on the side, I got 2x over 2. So now, because the denominators are the same, I can actually subtract the top portions, the numerators. And when I do that, I get 3x over 2, and that is the height of the rectangle. Okay, remember that the last step of this problem is to find the area of the rectangle. And if you can recall, the area formula for the rectangle is length times width. And so length here, we've already known that that was a 5. And a moment ago, when we found the height of the rectangle, in this case, it can also be looked at as the width of the rectangle, so which is always the shorter side of the rectangle. So remember, we found out that the height or width of this rectangle is 3x over 2. Don't be alarmed that it's not an actual number. That is fine. So at this point, again, we are multiplying length times width to get the area of the rectangle. And so we say 5, which is length, times the height, which is 3x over 2, equals 15x over 2. So notice here, when you're multiplying a whole number in a fraction, that there is no rule for you to make sure that denominators are the same. There is no rule about denominators at all. Just make sure that you're multiplying your whole number to the numerator of your fraction. That's why I have 15x over 2 in this answer. And that is your final answer.